Okay, so in this video we're going to be learning about we're going to introduce ourselves to this idea of a unit circle. This is going to be an important concept for this unit in trigonometry, and it's especially important when you get into FST next year. You'll be doing a lot more with the unit circle then, but we're going to be just starting out today with introducing the concept of the unit circle. Now, the reason why it's called a unit circle is because, for one, it's in the shape of a circle. Its center is at the origin, which would be the point 0, 0. The radius of the unit circle is 1 unit, thus a unit circle. Now, we haven't talked much about rotations, so let's talk about that for a second. This was covered in Chapter 4, which we skipped, but it's a very simple concept as far as what a rotation is. We use a capital letter R to represent a rotation, and the sub number represents how many degrees the rotation is. So, like I have written here, this R sub 60 represents a rotation of 60 degrees, and rotations, when the degree is positive, is counterclockwise. So, if they say find a rotation of 70 degrees, by the way, these our rotations always start at this point here, at the point 1, 0. So a rotation of 70 degrees, well, 90 degrees would be up here, so 70 degrees we'll say is right about there. So that would be a rotation of 70 degrees. That means the angle that's formed here, would be a 70-degree angle. Now, we're trying to figure out in this problem, what are the coordinates of that image 1, 0? So if I were to move the point 1, 0, 70 degrees, so it'd be counterclockwise, what would the new coordinate location be? So it's going to be, we're looking for an x and a y here. Now, if we think about what x and y means, x represents the horizontal distance that the point is moved, and y represents the vertical distance the point is moved. So its new location is the point x, y. Well, you can see that we get a triangle there. So I'm going to blow this up a little bit here. So this represents our 70-degree angle. Our short leg here is x, our long leg is y. And your hypotenuse, if you notice, is the radius of the circle. Well, we talked about the radius is going to be 1 unit. So I want to figure out my value for x. So if I want to find out what x is here, I'm going to use, this is the adjacent leg to the 70-degree angle, and the hypotenuse is 1. So the cosine of 70 uses the adjacent leg, which is x over 1. So if I multiply both sides by 1, well, it's going to stay the same. So in other words, to find x, I'm just going to take the cosine of 70. And the cosine of 70 ends up being 0.342. That's my value for x, which makes sense because if you look at my diagram here, if this is 1 unit where I started out originally, this new unit is less than halfway, so it's about 0.342 units away from the origin. So my value for y, if I want to find that, well, y is across from that 70-degree angle, or it's the opposite leg, and we're still going to use 1. That's my hypotenuse. So it's going to be the sine is the opposite, which is y, what we're trying to find. So the sine of 70 equals our opposite leg, which is y, over our hypotenuse, which is 1. Again, if I multiply both sides by 1, the sine is going to stay the same. So it's going to be the sine of 70, which gives me I can round this to 0.94. So the coordinate, our solution, the new location of where 1, 0 would be if I rotated it 70 degrees counterclockwise, would be at the point 0.342 and 0.94. That would be my new location. Now that's a lot of work just to figure out what a coordinate would be, a location would be, is drawing out the unit circle, doing all this math, drawing all these triangles. It's kind of a pain. There is a faster way to do it, but there's a reason why we did this longer way, so we could see visually what's going on. Because no matter where I pick a point on my circle, the hypotenuse, the radius, will always end up being 1. The side across from the angle that we'd be looking for is always going to be y, so we're always going to use sine to find out what y is. the side adjacent to that angle is always going to be x, so we're always going to have to use cosine to find out what the x is, which brings us to this definition, dealing with the unit circle. Every point on the unit circle is represented by a value for x and a value for y. Well, if we're looking for the cosine of an angle, or the sine, if we're looking for a location on that unit circle, and if I know the rotation, if I know the angle, to find the x value, I would just take the cosine of that angle. To find the y value, I just find the sine of the angle. So you don't have to write everything down, you just have to, I would write down this unit circle and this definition, meaning that, an easy way to remember this, because sometimes it's real easy to think that sine, because on your calculators you see sine, then cosine, then tangent. We memorize the ratios as sine, then the cosine, then the tangent. But here when we go to graph it, it's actually the cosine that comes first and then the sine. Well, an easy way to remember is that, remember this is an ordered pair. So the x and the y go in alphabetical order. Well, so does the cosine and the sine. They go in alphabetical order. So that's an easy way to keep this straight. So if I'm asked to find a rotation, this point 10 under a rotation of 50 degrees, I don't want to sit here and do this unit circle like we had to do last time, so I can use this shortcut. And I can say, well, to find out what the x value is, I'm going to take the cosine of 50. To find the y value, I'm going to take the sine of 50. So my answer here, if you take on your calculator the cosine of 50, that's going to end up being, we'll just round it to 0.64. And the sine of 50, when you do that on your calculator, you end up getting 0.77. So that would be your coordinate. If you rotated 10 under a rotation of 50 degrees, you'd end up at the location of 0.64 and 0.77. So let's talk more about the unit circle. So here I've drawn one out. You want to do the same. You don't have to put these four, if you're doing this, if you're writing these notes out on your own, you don't have to put these 4 spots in the 4 quadrants. It just so happened to be that the unit circle that I drew just ended up here. So you can put, if you're doing this in your own notes, you can write it like this instead. But anyhow, let's talk about these 4 corners, these 4 points. I guess a circle doesn't have corners, but you'll understand what I mean here in a second. So first off, remember we said that all of our rotations start over here at this point. So this is what we call, this is the point 10. This here would be the point on our y-axis, would be the point 0, 1. This point down here on our x-axis to the left of the origin would be the point -1, 0. And this point down here on our y-axis would be the point 0, -1. Now again, we always start at that location. So if I were to rotate that point 90 degrees, we'd end up here. So that would represent a 90-degree rotation. If I rotated another 90 degrees, I'd end up down here. Well, that means this would be a total of 180 degrees from my starting point. If I rotated it another 90 degrees, that would bring me down here. So this is 270 degrees from my starting point. And then that brings me back up here, which would be a full rotation, would be 360 degrees. So now, remember what we just talked about. Each of those locations represent a sine and a cosine. So if I was asked to find the cosine of 90 degrees without my calculator, the cosine of 90 degrees would be 0. Because remember, my cosine would be my x value of the angle, and my sine would be the y value of the angle. If I was asked to find the sine of 270 degrees, my answer would be -1. Because my sine would be the y value of 270 degrees, which is at that location, 0, -1, so the y value is -1. So let's look at these problems here that they give us in our notes. So to find the cosine of 90, well, the cosine of 90 is going to be right here where its value is 0. Let's go down to C. The sine of 270 degrees would be, well, the sine would be the y value, which is -1. If I'm asked to find the sine of -180, now here's something to know. We always rotate. When it's a positive degree rotation, we go counterclockwise. When it's a negative degree rotation, we go clockwise. So sine of -180 would bring us over here to the point -10, so the sine would be 0. Or if I'm asked to find the cosine of negative 90, cosine of negative 90 would go backwards, would go clockwise, so that brings us down to the point 0, negative 1. So the cosine of that would be 0. But what if we have more than one full rotation? Let's look at these next problems. First off, I'm going to copy this so I don't have to redraw it. So we're going to look at some rotations here that are more than 360 degrees. So you might want to put this in your notes. This would be good. This represents the first 4 full rotations around a circle. 1 rotation around the circle would be 360 degrees. 2 full rotations around the circle would be 720 degrees. And 3 rotations would be 1,080. 4 would be 1,440. The way you get this is you just multiply 2 times 360 to figure out 720. 3 times 360 would be 1,080. So 10 full rotations would be 3,600 degrees because you take 360 times 10. So whatever the rotation would be times 360 would give you the total number of degrees. So let's look at some of these. Here we have this first one is sine of 630 degrees. Well, that's more than 1 full rotation. 1 full rotation would be 360 degrees. 2 full rotations would be 720 degrees. So it's not quite 2 full rotations. So to figure out how many degrees past 360 this would be, you're going to take 630 minus 360. Well, when we do that, you're going to end up getting 270 as your answer. So in other words, the sine of 630 degrees is the same as the sine of 270 degrees. So now if I look on here, 270 degrees is going to be at the point 0, negative 1. So the sine of 270 would be negative 1. So the sine of 630 degrees would be negative 1. Let's go diagonally down to D there, where it says the cosine of 810 degrees. Well, 1 full rotation is 360. 2 full rotations would be 720. So it's more than 720 degrees. So it's more than 2 full rotations. It's another 90 degrees past that 720. So it's this would be the same as the cosine of 90 degrees. Because 720, or if you take 810 minus 720, that gives you an extra 90 degrees. And the cosine of 90 degrees would be equal to 0. So your answer here would be 0. Now when you're dealing with negative rotations, it's a little bit trickier, because you want to remember that we're going in the opposite direction. So it's going to a negative degree rotation is going to be slightly different. So first, cosine of negative 900. Let's look at letter B there. That means that it's 2 full rotations, because 2 rotations would be negative 720 degrees. But it's another 180 degrees past that. If you're not sure, you can ignore the fact that it's negative for right now. 900 minus 720 is going to be 180. So cosine of negative 900 is the same as the cosine of negative 180. Well, the cosine of negative 180 is negative 1. So in other words, the cosine of negative 900 would be the same as the cosine of negative 180, which is negative 1. Now the cosine of negative 180, if you want to look at this as being a positive degree rotation, that's also the same as the cosine of 180, which may seem like common sense, but let's look at the next one. The next one here, we have the sine of negative 1,170 degrees. Well, 3 full rotations would be 1,080 degrees. So this is a little bit more than 3 rotations in the clockwise direction. But how many degrees more than that? Well, we would take 1,170 minus 1,080. That's going to give us 90 degrees. So the sine of negative 1,170 is the same as the sine of negative 90 degrees. Well, if you look at negative 90 degrees, that's right here. That's the same as a positive 270 degrees. If you're not sure what it's the same as, you can always take 360 minus 90, and that would give you a 270. Now, I would accept either one of these, but either one is going to give you the same answer. Your answer here, the sine of that is going to be negative 1. So that's the unit circle. We're going to be So this section here introduces the unit circle. On Moodle, you'll see that there's also a review worksheet that's going to come up next. That's going to review so far everything we've done with trigonometry. So the first page, front and back, is going to be dealing with right triangle trigonometry with the sine, cosine, and tangent. And then the last page and a half is dealing with more practice problems like these. So it'll give you more practice if you don't quite understand or if you feel like you need that extra practice. That's what that's there for. So with that, good luck on your assignment.